Lambda calculus. Lambda calculus is a core of the functional programming languages, or well, we can argue that most of the functional programming languages out there in the market models the lambda calculus as its core. Okay? And it consists of lambda expressions as well as some evaluation rules. So let's consider the expressions. So the lambda expression defines the valid syntax of the language. Okay, typically we use the following EBNF form to denote the definition of expressions. So sometimes we call it lambda expressions, sometimes we call it lambda terms, but they refer to the same thing. So we typically use the symbol E. Okay, when an expression could be either a variable. Okay, this is a value variable, or a lambda abstractions, which takes in a formal argument x and whose body is another expression E. Or the third possibility for lambda term would be a function application where we apply one expression to another. So over here, I'm already using the notion of // to denote the lambda, which is make it closer to Haskell syntax. But in some cases, you will see people will use the lambda symbol, okay, to represent the lambda abstractions. Write lambda to denote same equivalent of this backslash, and a dot, which is the equivalent separated between the formal argument x and the function body E. So instead of using the right arrow like in Haskell. Lambda expression itself is pretty ambiguous. For example, given these expressions, lambda x that return x and applied to lambda y that return y, this seems to be a function application on the top level where you have a lambda abstraction in the blue, highlighted in blue, and its actual argument is another lambda term, which is highlighted in purple. Okay. So there's another way of parsing is that if you look at the whole term itself is just one lambda abstraction, where the x is the formal argument of this entire lambda abstractions, and whose body is basically apply x to another lambda term /y right arrow y as its actual argument, and this application will become the body of the outer lambda abstractions. So this is a second way of parsing the same syntax. This ambiguity, this confusion or this ambiguity, we would apply or by adding some parentheses around the needed terms. Okay, for example, to this ambiguity that example that we have seen earlier on, we simply put rounded parentheses around the first lambda term and the second lambda term, and so on and so forth. Okay, in most cases, in most of the languages, in the absence of the parentheses, we assume that the lambda abstractions, okay, would take a least precedent compared to the function applications, which means that, for example, if we didn't include any parentheses here, so the second pass is always preferred.